Hello everyone, today in this series we will be discussing on the GATE Textile and Fiber Engineering GATE questions. So starting with the 1 mark questions of GATE 2023, it says that the amide linkage is not present in. Options are wool, aramid, lyocell and nylon 66. So if we talk about the amide linkage, so you know that amide linkage is NH2 linkage. So it is present in wool, aramid fibers, as we know, Kevlar, Nomex, and nylon 66 and nylon 610. These all are amide, polyamide fibers. So these all are the amide linkages is present in all of these. So in which it is not present, this is asked. So we have to say that it is not present in option C, lyocell. Because if we talk about the lyocell, then lyocell is a type of a rayon that is made up of from regenerated cellulose. While in rest other cases, wool, aramid, nylon 66 contain NH2 linkages. And lyocell contains OH bond, hydroxide bond. So this hydroxyl group is present in OH. So the hydrogen bond is formed between the adjacent cellulose molecules of the lyocell. So if we say all of these, then the polyamide is not present in lyocell. Rest all other cases polyamide linkage is present. I think it is very much clear. Now coming to the next question, it says that in the amorphous phase, the polymer chains prefer to be in random coil conformation 2. The options that are given are to maximize entropy, maximize enthalpy, minimize entropy and minimize enthalpy. So before coming directly on to the question, we need to know what is enthalpy and what is entropy. So if I talk about enthalpy, then enthalpy is a thermodynamic quantity that is equivalent to the total heat content of the system. So it is equal to the internal energy of the system plus the product of pressure and volume. We already have read about all of these in our 12th standard. So internal energy of the system plus product of pressure and volume, this is total enthalpy of the system. And what is entropy? Entropy is randomness of the system. Randomness. If in an open state, if I talk about in an open state and in a closed state, so generally in an open state the entropy is very much higher, and in closed state where all boundaries are closed, so the entropy is lower. So in case of amorphous, the chains are arranged in random coil. Random coil means they are arranged in not in a particular manner. They are arranged in random coil because so as to maximize entropy, because the polymer chains want to move from one place to another place. So the objective is to maximize the randomness, because so that they can move freely in case of amorphous. Whereas in case of crystalline, what happens is the polymer chains are arranged in a definite order, and the bonding is between these two polymer chains, that is known as intermolecular bonding or intramolecular bonding, depending upon the type of the molecule that is used. So if the bonding is strong, then the molecules cannot move from one place to another place. But whereas in case of amorphous phase, the polymer chains are free. If they are free, then they can move in any direction. If they can move in any direction, then the entropy or the randomness of the system is improved. So the option A is the correct answer. I think it is very much clear to you. It says that the copolymers are present in nylon 6 fiber, nylon 66 fiber, acrylic fiber or PET fiber. So copolymers are basically present in acrylic fiber. If you have read about the acrylic fiber in detail, then this acrylic fiber is a type of a synthetic fiber that is made from the copolymer of acrylonitrile. along with vinyl acetate and methyl acrylate. Whereas nylon 6 is made from single monomer, that is known as caprolactam, and whereas in case of nylon 6 it is made from two monomers. Copolymers are typically the same type of polymers, whereas nylon 6,6 is made from different types of two monomers, that is known as hexamethylene diamine and adipic acid. Hexamethylene diamine and adipic acid. And PET is made from the monomers of ethylene glycol and terephthalic acid. Terephthalic acid. So this option C is the correct option. Means acrylic fiber. The copolymers are present in acrylic fibers.
So this question says that this is a chemical processing question that says that in wet spinning of acrylic fibers, two-way mass transfer is involved. One-way mass transfer is involved. Coagulation bath having spin rate contains only solvent, and the fourth option says that coagulation bath having spin rate contains both solvent and non-solvent. So the options which is the correct option. So this is a direct question. If you have read about the spinning process, this acrylic is made by wet spinning process, and what are the types of spinning process? Melt spinning process, dry spinning process, wet spinning process, and dry jet wet spinning process, and also the gel spinning process in which UHMWP fibers are made. UHMWP ultra high molecular polyethylene fibers are made. These are manufactured by gel spinning process. The advantage of this type of manufacturing process is the orientation or the structure, fiber structure is very crystalline and oriented as compared to the other type of spinning process. So in case of wet spinning process, if we talk about, then it involves two-way mass transfer and coagulation bath having spin rate. It contains both solvent and non-solvent also. So I think this is a multiple type of question. Two-way mass transfer is involved, and coagulation bath contains spin rate. And so if I discuss about the manufacturing process of this, then you can say that these are dope from where the fibers are put into, and this is a metering pump which measures the quantity, and this is a filter type of filter which filters all these things. And in case of wet spinning process, the fibers goes from here, and this is a coagulation bath that is there, and this is known as spinning bath, and the fibers come from here to here. The coagulation occurs, and then the precursor is there, and this is PAN precursor, polyacrylonite precursor, and then the fibers are put from here to other parts of this. So this is a typical line of this wet spinning process of acrylic fibers. So I think this is clear.